Hello all, this is Y.Renuka from 4th ECE-C, appearing roll number 19BQ1A04H5, and now I am going to discuss about signal distortion in optical fibers topic from optical communications. Signal distortion in optical fibers. Signal attenuation is also known as fiber loss or signal loss or power loss. It determines the distance between the transmitter and receiver. The distortion mechanics in a fiber cause optical signal pulses travel sufficiently far. They will overlap with neighboring pulses, thereby creating error to the receiver output. The signal attenuation mechanics limits the information carrying capacity of the fiber. Attenuation. The loss of the light power as it propagates along the length of a fiber. The major role is determining the maximum distance between the transmitter and receiver. The basic attenuation mechanics in a fiber are absorption, scattering, and radiative losses of the optical energy. The absorption is related to the fiber material. Scattering is related to both fiber material and with the structural imperfections in the optical waveguide. Radiative losses originates from the perturbations of the fiber geometry. Attenuation units. A light travels along a fiber with its power decreases exponentially with distance. Alpha dB is equals to 10 log 10 of P in by P out. P in is input power at origin, P out is output power at Z position. If P0 is the optical fiber at length origin 0, Pz is the power at the distance Z from the origin. P of Z is equals to P0 into e power minus alpha suffix P into Z. Alpha P is 1 by Z into ln P0 by Pz in kilometer inverse. Alpha P is fiber attenuation coefficient given in units of kilometers inverse. Designating the parameter by alpha B per in dB per kilometer is equals to 10 by Z into log of P0 by Pz is equals to 4.343 alpha P in kilometer inverse. Now coming to absorption by atomic absorption. Absorption is caused by three parts. They are absorption by atomic defects, intrinsic absorption, and extrinsic absorption. Absorption by atomic defects. Atomic defects are imperfections in the atomic structure of the fiber material. Examples they are missing molecules, high density clusters of atom groups, or oxygen defects in the glass structure. These absorption losses are negligible compared to intrinsic and extrinsic losses. The total dose a material receives is expressed in the units of radial silicon, which is a measure of radiation observed in bulk silicon. The unit is defined as 1 radians per silicon is equals to 100 x per gram, or 0.01 joules per kilograms. Higher the radiation intensity, more the attenuation. And here this is the graphs for induced loss versus dose in radiation of silicon to the induced loss for time after irradiations. Extrinsic absorption. It is due to impurities present in the fiber material such as transition material impurities and OH ions. A major source of attenuation is from transition of metal impurity ions such as iron, chromium, cobalt, and copper. These losses can be up to 1 to 10 dB per km. The effect of metallic impurities can be reduced by glass refining techniques. Another major extrinsic loss is caused by absorption due to OH ions. Impurities dissolved in glass. The hydrox groups are bonded into the glass structures and have fundamental stretching vibrations. And the graph is about absorption wavelength versus attenuation. And it has three overtones, that is first overtone, second overtone, and third overtone. First overtone at 1400 nanometers wavelength, and the second one is 950 nm, and third one is at 750 nm. The figure is about absorption spectrum for OH group. Intrinsic absorption. It occurs when a material is an absolutely pure state with no density variations, impurities, and inhomogeneities. Intrinsic absorption results from electronic absorption bands in UV region and from atomic variation bands in near IR region. Attenuation spectra for intrinsic is alpha U is equals to 154.2 x by 1146.6 x plus 60 into 10 power minus 2 x in e power 4.63 by lambda, where lambda is the wavelength, and alpha U is equals to C into e power e by e naught. The graph given is versus photon energy into loss per dB per km, and this represents about the UV absorption. Thank you.